Good morning, Sujata. Sending link with our. Now look here, I'm starting statistics today, and along with sample paper revision also I was giving. So sample paper revision plus statistics, because statistics one topic is left. The topic has to be started as fast as possible. Some students are having exams early, some students are having exams late. So I decided statistics and probability. Probability one more time I'm going to give revision. Just now statistics I'm starting. Just take care of statistics first. Now look here. Among statistics, first you need to understand class 11th what you have studied. That is very very important. But before that, you need to understand that what is the meaning of mean deviation. What is deviation? Anyone who can answer what is the meaning of deviation, beta? What according to you is deviation? See, you need to understand that whenever central tendencies are there, central tendency in the sense the tendency to which you need to understand this part, the tendency to which bring the values in the middle sections are called as central tendencies. Understood not? So for central tendencies, we know that the central tendency means the data to which the data or the degree to which. Just check this one out. Payoja, good morning, beta. The degree to which numerical data tends to spend, the degree to which numerical data, the degree to which numerical data tend to spread about an average value. So here the entire talk is about average value. So if somebody will be asking you average, means the value which is exactly coming as average, that is coming as dispersion of the data. Understood or not? It will be called as variation. Understood? So when we are talking about nearly the central values, the central part, then it is exactly considered as average. Okay, so centrally it has to be localized. Got it? So if somebody will be asking you this question, we will be saying that the degree to which numerical data tend to spread about an average value, tend to give an average value, is called as variation or dispersion of data. What it is called as? Is called as variation or dispersion. Understood. Variation or dispersion of data. Dispersion of data. This is called as variation and dispersion of data. Now, for variation and dispersion of data, how we are exactly finding? Good evening, good morning, Siddharth. Siddharth, just now we started statistics with us because statistics portion is important, because in that sample paper statistics was there. Just moment we will finish statistics. After understanding what and all is there in the statistics, we will start the sample paper again with chapter wise division. One more time, probability also I am going to teach. Okay. So now look here. When you talk about measures of dispersion means what? Deviation. How deviation is measured? See, simple topic. When you do some experiment, at the time of doing experiment, your data will be very much near about. Like you are checking some digits. That digits means one time experiment you got 44 value, next time you got 43.5, next time you got again 44, next time you are getting 43.2. So like that. So what is exactly the central value? Because you have to present a data, a much accurate data, and every time because of some mistakes the variations are shown. So that variation has to overcome, because the person who is checking your project, or the person who is checking your experiment, will not be highly interested if they will be coming to know that every time variations are coming. So to overcome the variations, we are finding this data. Means we are going to disperse it, and we are going to find the central part. Central part means one mean value out of deviation. Understood? Out of dispersion, one single mean value to come, and that mean value will be your perfect value. Means after that, people will be telling that, okay, this is the value and this is accurately coming. Either whatever error is there, instrumental error is there, then no precision error will be there, that too also it will come centrally, that value. So only it is considered as measure of dispersion. So measure of dispersion will be divided in many parts. We are not going to waste our time into that. Just understand here how we are going to talk about this person. We are going to talk about this person by finding the range. We are going to talk about this person by finding the mean deviation, standard deviation, like that. Deviation means every time how much deviation is coming, the deviation has to overcome. That deviation part has to be measured. That is called as mean deviation, measure deviation. We are going to do that. Without wasting time, first we will understand what is range, because range is also a part of central tendency. So first we are going to understand what is the meaning of range. Now in junior classes, class 9th, first ungrouped data's range I am teaching you, then grouped data's range I will teach you. What is the meaning of range in ungrouped data? Look here. If minus 3 is there, 4 is there, 8 is there, 0 is there, minus 5 is there, 8 is there, and then minus 6 is there, then 18 is there, and then 32 is there. Then what is the range of it? Range formula is max minus minimum. Max minus min. That is the highest value minus least value. That is considered as range. Highest minus least will always be considered as range. So let's see what is the range. Range formula will be highest minus lowest. So here, what is the highest value? Many times the teacher will be telling you, write this in either ascending order or descending order. Okay. So for safety, what we are doing is, okay, first we are writing in ascending order, and then we are finding the range. So because first number is minus 6, then minus 5, then minus 3, then 0, then 4, then 8, then 8. Check minus 3, 4, 8, 0, minus 5, 8, minus 6, after that 18 and 32. So what is the highest and the lowest? So here range will come with that. So maximum value is 32 minus of minus 6, because 6 is the least and 32 is the maximum part. Okay. So here it will become 32 plus 6. So total value is coming as 38. This is a way of finding range. Maximum minus minimum for ungrouped data. Range is maximum, highest minus lowest. So the highest value minus the lowest value will give you range. This is a simple formula. Now, what is exactly range? Maximum minus minimum will become range for you. So once we are writing range, now here range is exactly a part of central tendency. Many times in MCQs they will be asking, you just see it is a part of central tendency. Okay. So after range, the next part is, this is for ungrouped data. Ungrouped data means many observations will be there, but there is not a proper interval in the observation. Then that type of observations are called as ungrouped. Okay, so this is ungrouped data. Ungrouped means here minimum, maximum values are not there. So that type of observations are considered as ungrouped. Now we are going to go for group. So if somebody will ask you what is the range of grouped data, so if group data they are going to write with frequency. Understood? So that means how many times the number has repeated in that interval. So now let's see. First example 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70. So 60 to 70 we have taken. And here numbers what is we are getting is 7, 15, 3, okay, 30, 24, 18 and 11. Then how to find the range of it? So what is the range of grouped frequency? So if grouped frequency is there, grouped frequency means this part will be called as lower limit. So whenever you write any number in group like this is called as lower limit. Lower limit means the starting limit. This is called as lower limit. This part will be called as upper limit. Okay, so one section is lower limit, one section is upper limit. Good morning, Rudra. Good morning, Beta. Beta, I am starting statistics because in that question paper, statistics questions were there. Finishing that part and sample paper again starting with probability teaching one more time. Huh? So this is upper limit and this is lower limit. Okay. Now class size. What is the meaning of class size? So if somebody will ask you what is class size is generally denoted by H, and this will be highest minus lowest. That is upper limit minus lower limit. Lower limit. So this will become with a class size. Means upper limit minus lower limit will become class size for you. So H generally we can height, size, we will be denoting it by H. So B minus A. So beta 20 minus 10 will become class size. So what is the class size here? This will become 20 minus 10. Class size will become H and that is coming as 10. But we have to find range, What is the range here? Can anybody tell me what is the range here? See, ungrouped so we understood. Highest minus lowest. For grouped, what is the range? For grouped also, same thing you have to do. For range, I am writing range. For range also here, what is the maximum value? What is the maximum limit? 70. What is the minimum limit? 10. So range will become 70 minus 10. It will become 60. That's it. Range is very easy for grouped data. Whatever intervals is there, no matter interval is in inclusive form or exclusive form. What is the meaning of inclusive and exclusive in statistics? It is a very important part that I am going to explain so that at the time of solving mean and median, it will not disturb you. Okay. So look here. This is called as maximum value and this is the minimum part. What is the range beta? 70 minus 10. The range is coming as 60. I hope you might have understood. To find the range, we have to just see the class interval. When the class interval is coming like this is exactly coming as grouped. Okay. Now, range we have understood for grouped and ungrouped. But I said one thing, that is inclusive and exclusive. What is the meaning of inclusive and exclusive? Maximum, they will not give you, they will not hurt you. For inclusive, exclusive, in exclusive part, it is very easy. But when inclusive will be there, their only problem will be there. So inclusive section one time I am going to teach. But before that, you check here, what is exclusive? So exclusive section will be there and inclusive section will be there. Now inclusive is further divided into two types, but that type is not in your syllabus. Only one type I am going to teach which is important for you. Now look here, exclusive section, if it is written 0 to 10, 10 to 20, 20 to 30, 30 to 40. Now beta, whenever you are starting, your major part is including 0, excluding 10. See, interval is same. You see 0 to 10, then 10 is repeated, 20 is repeated, 30 is repeated. Understood? So 0 to 10, 10 is repeated. But here we are not going to consider 10, because if you see very nicely, 10 and 10 is repeated. Got it? So here, if 10 and 10 is repeated, just in case, how we are converting this into group? Just first day, so I'm giving you all prior information so that you will not get confused. So if any numbers are coming between 0 to 30, like 4, 3, 8, 0, 8, 10, 12, 20, 20, 30, 8, 8, 4, 5, 6, 11. So like this much number is given. Now this is ungrouped. This is ungrouped. We can convert it into group and make it into frequency. How we will do? We will write 0 to 10, 10 to 20 and 20 to 30. Understood? Now here 0 is included. So if I am going to include 10 here also, 10 here also, means 10 will come 2 times, which we can't do. So here for frequency means how many times, what is the meaning of frequency? The meaning of frequency is how many times an observation is repeated is called as frequency. Understood? Like here, what is the frequency? 8 is coming how many times? So frequency of coming 8 is 3. That means 8 is that number which is repeated 3 times. So how many times a number is repeated becomes the frequency of that number. So here frequency, but beta here our main duty is to write this part. 0 taken, 1, 2, 3, 4, 5. Okay, here 6, 7, 8, 9. So I am taking frequency is 9. But I did not include 10. Did you notice? Because if you will start including 0 and 10, the number will become 0 to 10, the number is 11 numbers are there. Here 10 to 20, again 11 numbers are there. 10, 11, 12, 13, 14, if you will count, 11 numbers are coming. 10 to 30, 11 numbers are coming. But here this number is repeated 2 times. That will collapse the entire central tendency. So what we will do? We will include 0, but we will not include 10. We will include 10 here, we will not include 20. In the observation, if initial limit we are including, that the final limit or the upper limit we have to exclude. So this is exclusive section. This is exclusive section. So exclusive is the upper limit will never be included. So here 10 will be included here. So now you start 10, 1, 2, 3. So this number is coming as 3. But 20 I did not include it here. Okay. So 20 will be included here. So here 21, 2. So 20 is coming as 2. But one thing, 30 is left. So can I include 30 here? No. You can't include 30 here. 30 to 40 you have to put. And after that 130 is coming, it will be included here. I hope you might have understood, and this is a way to approach that is exclusive system. In exclusive system, lower limit will be taken, upper limit will not be taken. Upper limit will be taken in another part, another interval. This is exclusive system. Now, what is the meaning of inclusive system? Whenever any inclusive system will be there, the inclusive system will not have connections. Understood? Like connections, like most of the time confusion is coming. Here 9 is written, then from here 10 is written. Okay. Now here 10 to 19 will be there. Now again 20 to 39 will be there. Now 40 to 0 to 9, 10 to 19, 20 to 39, then 40 to 49. Now this is exactly consisting of 10 numbers. 10 numbers are there. 19 to 10 if you are including. 10 numbers are there, but upper limit and lower limit is not inclusive. They are not, upper limit and lower limit is not same. In that interval, it is problem for finding the major tendencies. So first what we are going to do, we will be converting it into external, this form, exclusive form. and then final value we will not include. Then how we are converting into exclusive form? So see how much they are deviating with. They are deviating with 10 minus 9. First you see formula is 10 minus 9 divided by 2. See here 20 minus 19 divided by 2. 20 minus 19 divided by 2. 40 minus 39 also you will do. 40 minus 39 divided by 2. Means whenever this, the next upper limit and this lower minus upper, whenever you will do, you will get the deviation. So here deviation is for what value beta? Deviation is for 1. So 1 by 2. 1 by 2 means how much it is coming? 0.5. Here also deviation if you will check 0.5. Here also deviation if you will check 0.5. So deviation whenever it is coming with 0.5. So there are certain frequencies, certain observations where deviations are also changed. Okay, that is different. In histograms only we are doing that. Okay, rather than that we are exactly going group frequency means we will be seeing this type of intervals only where range will not keep on changing. Their range are very much synchronized with one deviation. Okay. So now beta what value is coming? 0.5, 0.5, 0.5. So how to convert this inclusive into exclusive? So now we are going to convert this inclusive into exclusive. This is inclusive with a variation of 1. Understood? So how to convert it? So we will do one work. 0 is there now. So for lower limit, formula is lower limit minus 0.5, upper limit plus 0.5. Means ki how much deviation is coming, that deviation divided by 2 will become something to be added in. So that variation will be added for lower limit and upper limit part. So how we are going to write this? It will become minus 0.5 to 9.5. Now from 10 if we will subtract 0.5, it will become 9.5 to 19.5. Now here 19.5 to 29 will be there. Now I just 19 to 20, 20 to 29. Correct only now. Then 29 to 30 to 39. I just skipped 10 numbers. So here 19 to 29. Okay. Now here it will become 29 to 39. Then 39 to 49. You see now perfect variation is coming, and everywhere you see this lower upper limit and this lower limit. This upper limit and this lower limit is now very much same. So this is exactly conversion of inclusive into exclusive part. And whenever you are writing exclusive, always remember that final this point will not be taken. Understood? And inclusive, you can take everything 0 to 9 because after that 9 is not repeated. Understood? So there are many ways where when you are not drawing graph, we can consider this, but the most important point here is this type given because the graph will be connective at that part. The graph will be exactly presented in a connective format. Understood? So this is the difference between inclusive and exclusive. I explained range, frequency, inclusive, exclusive, class, size. Okay, so these are the part which is important for finding deviation. Understood? So now we are going to talk about mean deviation. Sometimes in an observation, you will do mistake in mean deviation. What is mean deviation? Now look at it. Central tendencies will be divided into many types. Mean, median, mode. So in class 10th, you studied mean. You know the formula of finding mean. Then you know the formula of finding median. And then you know the formula of finding mode. So all the three central tendencies value you know how to find. Okay. But that is not enough. Okay, now understand one thing. The mean deviation will be average. Okay, so average of deviation. Mean deviation will be average of deviation for every observation. Average of deviation of every observation. So here now we are exactly, who is there? Okay, Vishnu. So now look here, beta. Average of every deviation will be coming. So how to overcome that? So first, the simple procedure is there. What is the simple procedure? First, we will start just a little bit, beta. I'm starting from basics so that you will not have any problem in any phases. Because many times directly, if some questions will be coming, means you must be the first one who can understand it from the grassroots level. Just 5 minutes of explanation means you will understand it nicely. Now, to understand with example, can I teach or with values? So just understand this. 10 observations are there. 10 observations. Okay, now the 10 observations are x1, x2, x3 till x10. So how many observations we are having? 10 observations. Understood. Now these 10 observations will be exactly having some central value if I want to find a mean. Mean means what, beta? Usually when you are finding mean, you are putting x bar is equal to x1 plus x2 plus x3 till x10 divided by 10. This will become mean. Chalo, come on, everybody understood? This is called as mean, beta. Understood. So this is exactly going to be mean. What if any number you have done mistake, calculation part, understood? So here one very important catch is there, like this will give you a central tendency. Central tendency means a central value. Got it? So whenever we find average, but average will be exactly wholesome somewhere, it will be hitting to the mean part. Mean part means the part which is near to the center. Near to the center means many observations are there. These are observations. Now these observations as data will give you mean. Okay, so these are mean values, and these are mean values of 50 students. Okay, but everyone just understand, everyone find were there to find the mean of observation. Like in a lab, 100 scientists are there. Every scientist got the same type of equipment, and all the 100 scientists did the same pattern experiment. Because whenever we are doing some experiment, it's not, we cannot rely on one person, we have to depend on many people. Understood? So here what happened is ki you, okay, just when I'm just explaining some part of mean variations and central deviations with her. So here, so now what happened is 100 scientists is doing experiment on the same data, same equipment, and what will happen? Speak Tamil. It is very difficult. Okay, that's respect it. I can't speak right now. So now look here. So what happened is all the scientists were finding the same value, then deviation will come because everyone can do some mistake. Understood? All people in different lab cannot give one single value on its own. Like if they are doing experiment on sample of COVID. Understood? So when the COVID, what you call that, the when the virus will be exactly duplicating, and when the virus with any type of antidote will have the time span of death or something, so calculation has to be very precise. So 100 scientists got the chance of doing experiment on that. What they did in different labs, and that data are exactly accumulately given to one agency. This agency has taken the data. Now they are feeding the data to get a central value, because now it has to find the central value. So to get the central value, it will just put it into some system. Once they have put into the system, what will happen? The system started some values, but one part will be there near the center when the values will be very much accumulated. So that means from a range of 0 to 100, the values are exactly concentric to one particular part. That is called as central tendency. Understood? The central tendency means out of all the observations, out of all the outcomes, the outcome which is very near to the target will be considered as central tendency, and beta that central tendency will be considered as the mean value. Okay, after deviation, these are deviations only now, because most of the scientists, they might have done some mistake, error. That error can be personal, instrumental, or many different type of, they don't know the correct way of finding, so all different type of mistakes done. But some scientists were there, out of 100 they were very near to the central value, so that part will be considered, and then it will be redefined and re-observation might be done. Okay, this range is 55 to 65 range, most of the values are coming between this, means that this is becoming the central tendency. Understood? So for central tendency, after finding mean, we are finding deviation. Understood? So these are all mean. Mean means the average value. After getting average value, also mistake is there. So what we are doing, we are finding the central tendency here. So this is the most important part. So now how to do it? For that, deviation finding is most important. How we are going to find the deviation? Let's check how to find the deviation. So for finding the deviation of every observation now, because accumulately, if I am checking for COVID virus, I will find time lapse now, time gap. Okay, 0 to 5 seconds, 5 to 10 seconds, 10 to 20 seconds. Like that I am doing. So 0 to 5 seconds, all the scientists did experiment. Understand this. Between 0 to 5, 5 to 10 seconds, everybody is doing experiment and trying to find. Understood? So one got value as 50. One got that 50 virus grown. Another value is getting as 55. But one scientist got 50, another scientist got 52. Like that, deviation started. So that deviation. Good morning, Sweta. So that deviation has to overcome it, and that is the most important challenge. So deviation has to be checked very properly. Okay, from which value the deviations are coming. Understood? Because 100 scientists from 0 to 5 seconds, they will be giving some value in this range only. Understood? 50, 51, 52 means the variation is coming very near to 50 only. It will not go very far. Means in one lab, from 0 to 5 seconds, 50 virus is grown. Another lab, 52 virus is grown. Another lab, it may not be 100. This is exactly not possible. So definitely deviations in mean has to be there. So that part has to be checked very properly. So we are doing this experiment. So now what is deviation and how deviation has to be found? Till here I hope children you are not having any doubt. So with every observation we will find deviation. So what is the formula for deviation? Deviation will become xi minus a. Understood? So first we have to find mean. Got it? After getting mean, so if A is the mean, so we have to measure the central tendency A, that is mean deviation. Measure the, what did I say? I have to find the, measure that central tendency. I showed you now, central one point was there where everything was very much near to, so that means we are very near to the experiment and we are very near to the outcome, but that outcome is not an absolute value. So between 0 to 100, if I am saying 50 is an absolute value, but everybody is not getting 50. So near to 50 will become our central tendency. Understood, beta? So when we are finding the central tendency, mean deviation will be calculated. Got it? So now how to find the mean variation? So deviation is coming as, deviation means little bit fluctuations in the value. So how to overcome deviation? Deviation formula will become di is equal to modulus of xi minus a. Understood? Xi minus a. Sounding very difficult? Let's solve one question and then understand. Because after that, mistakes will not come. So let's see. First, we will find mean. So one observation for mean deviation for ungrouped data we are going to do. So for ungrouped data when we are going to do, we will get some idea. Okay, fine. How to do it. So xi is coming. So xi observation means we are going to calculate for 5 observation. Okay. So 5 observations are there. Just randomly I am giving you 10, 12, 10, 19, 18, 6. So 5 are there. X1, X2, X3, X4, X5. Now beta, here no numbers are repeated, so frequency will become 1. Okay. See, all the numbers are distinct. Distinct means the one which is not repeated are considered as distinct numbers. So all the distinct numbers are there, nothing numbers are repeated. So we are going to find mean. Mean will come how? 12 plus 10 plus 19 plus 18 plus 6 divided by 5. Done. Now we are going to find the mean of it. Can we calculate this one? Okay. So 5 ones are 5, 5 fives are 25. So this is coming as your mean. Till here is it okay? Mean finding was difficult? No. Mean finding was not difficult. But now we are going to find deviation from mean, because mean is symbolism of okay, fine, this is exactly the mean coming. Understood? Mean means the number must be very near to 15. Okay. Now how to find the deviation from mean? So now our box we are going to make it ready to understand deviation. Got it? Then formulas. One by one with every solving questions, I will give you formulas. So here it will become xi beta 5. How many are there? First is 12. Then it is 10. I am not arranging in particular order. 19. Can I arrange it first? 12, 10. How the numbers came to me? Same way I am writing. So 12, 10, 19, 18 and 6. So this is the observation. Now beta we have to find deviation of particular observation. So for finding the deviation of particular observation, we will be writing xi minus 15. So what is your A became? Just now I told you, na, A is mean. What was our formula? Our formula was xi minus A. So that means what is A? A is the mean or the central tendency. Okay. So now here, one by one you have to write. So it will become 12 minus 15. Since modulus is there, it will become modulus of minus 3. It will become 3. 10 minus 15. See, every number got deviated from mean. What is the mean? Mean is 15. So all the number, all the observations are deviated from mean. Means once you started an experiment, 15 should be the outcome. But 15 outcome is not coming. Every time, one time 12 came, one time 10 came, one time 9 came, 19 came. Your mean value was 15. Understood? That is after your observation, you should be supposed to get 15, but you are not getting. That means how much you are deviating? First person when he did experiment, he got 12. How much he deviated? 3. Second person did experiment, how much he deviated? 5. Next person did experiment, how much he deviated? He or she deviated 4. Next person did experiment, how much he or she got deviated? 3. Next person did experiment, how much that person got deviated? 9. I hope you might have understood. Like this part, 16 is there, or 6 or 16? 16 was then only 65 will come. So here it will be coming as that much variation should not come, so I put 16. So here it is coming as 1. So now these are deviations. Now we will calculate the entire deviation with a 3 plus 5, 8, 8 plus 4, 12, 12, 13, 14, 15, 1, 16. Understood? So the entire deviation part is coming as 16. Now how to write the formula? So mean deviation. Mean deviation is equal to summation of I is equal to 1 to n deviation di. Deviation part directly we can write, or we can write xi xi minus x bar. X bar is our mean and then it will be divided by n. Okay, so here what is the deviation coming with? 16. And for how many observations? 5. So deviation is coming as 3.2. So this is exactly the way to find the deviation. Is it clear? Till here we got deviation part and that is mean deviation. For mean deviation, what is the first target? For mean deviation, you have to first find mean. Got it? Once you got mean data, after getting mean, every number is diverted from mean. Every number is getting deviated from mean. How much deviation is there? 3, 5, 4, 3, 1. I told you now the deviations will not go very high. Immediately I changed the number, I saw calculation 16.6 was there. So that part, so mean deviation will be exactly coming very near to that part. Once the mean deviation is coming 16. Now how much very fluctuations are there? 3.2. Till here clear? So this is exactly about mean deviation. Now beta mean deviation will be there, median also deviation will be there. So whenever you will be finding any central tendency, whatever deviations will be there, that we can be able to rectify that the mean deviation is from maximum. These people are having a diversion from for 15, is from mean 15, the diversions are coming as 3.2 diversions are there for most of the numbers nearby to that mean deviation. I hope this is clear to you people. Come on, say, did you understood about mean deviations, Peter? Quickly inform mean deviation for ungrouped data because for group data also we have to do deviation. Still it is done. Everyone understood? This is for mean deviation. If you have understood, you say. If you have not understood, means I will explain you one more thing. This is for mean deviation, beta. Shall we do one more time? Shall we try to understand one more time deviation? Try to understand. So now look here. We will again do one question to find the mean deviation. One question we are going to solve. Question is just note down. You have to find the mean deviation of number 50, 40. Okay, calculation only is very important here. 22. Okay, 35, 45. Numbers are not repeated. 60. Okay, so till here 1, 2, 3, 4, 5. We'll take 5 numbers first, not more than that. So 5 numbers we have taken to find the mean deviation. Again with the observation x bar will be equal to 50 plus 40 plus 22 plus 35 plus 45. Can you solve and show me? So here it is coming as 5 numbers are. So here okay. So we'll start. Yes, it's maths only, sir. So the mean is coming as 38.4. So here, whatever mean is coming beta, once you have got 90, 90, after that this part we have added, total it is coming as 80 plus 90 and then 22. So 19, 192 we got, after 192 we got, we divided it by 5. After dividing it by 5, we got 38.4. So once 38.4 is coming, we are going to find the deviation. So deviation for numbers will be written as xi. So here it will become 50, then 40, then 22, then 35, and then 45. Now deviations will be written as 50 minus 38.4. Okay, and then 40 minus 38.4 in modulus you have to write, then 22 minus 38.4, and then 35 minus 38.4. Okay, and then next 45 minus 38.4. So whatever values are coming, that you have to write as deviation part. So once you are writing the deviation values, so here 50.0, 38.4, it will become 6, 1, 1. So it is coming 11.6 value will come. Now 40.0, 38.4, it is coming as 6. 9 minus 8 is 1. So here 1.6 is coming. Then here it will come 22, 38.4, 4, 6. So 16 minus means it will come plus only 16.4. And then check, I'm writing the values one time, check 38.4, 35.0, 3. So it will become 3.4. And then below 30, 45. 45, 38.4, 10 minus 4 will become 6. Now 14 minus 8 will become 6. Okay. So 6.6. Now this is deviation. Now how to find the mean deviation, beta? So mean deviation will be addition of everything. 11.6 plus 1.6 plus 16.4 plus 3.4 plus 6.6 divided by 5. And this will become your mean deviation for ungrouped data. Understood? So direct formula we are going to implement here and solve the question. So here just we need to calculate this part and just have to write the mean deviations. Okay. So now look here, it will become 11.6, 1.6, 16.4, 3.4 and 6.6. So it is coming as 39.6. Got it? If we will cancel, 50 will come. So here 50 will divide 39.6. Easily it will come. So it is coming as deviation is coming as 7.92. So deviation is coming as this much. So this is exactly the way to solve the deviations. I hope till here it is clear that how to find the deviations. So we have done deviations for ungrouped data and we have found the deviations for mean one. Okay, so mean deviation. Whatever we have calculated today, it was for mean. Okay. So this is the part for mean deviation. For median also same thing will be there. First you have to find the median. Once you are finding the median, you have to just subtract median from every observation and then you have to find the median deviation. Understood or not? So that part again deviation sections will be there. So beta, what we are going to do is next class I'm going to teach you about median for ungrouped and grouped part and we are going to solve questions related to it. Along with that probability also I told you one more time I'm going to start revising probability and I'm going to teach you how to solve probability questions with much fluency. No mistake will be there and concepts understanding is one section we are going to do in that. Okay. Bye everyone.